Okay, covalent compounds, atoms that are sharing electrons with one another in order to get their stable octet. As we quickly mentioned last week, they occur from one nonmetal to another. Not many nonmetals in the periodic table, and yet they make up heaps of the different materials around us. So really important for us to get an understanding of this. So in the next three topics, we're going to look at how these atoms join together, how they make these covalent compounds. We're going to learn to draw out these structures to be able to see this sharing for ourselves. When we're doing that, we're going to draw what we call Lewis structures. So here I have a Lewis structure for acetic acid. Acetic acid is what you find in vinegar. So vinegar at home is just a 4% solution of this acetic acid. These Lewis structures show us which atoms bond with which other atoms. It shows us how many electrons they share as part of that bonding process, and it shows us other valence electrons that are around that aren't explicitly involved in the bonding process. What we're going to do now is we're going to walk through a few very simple Lewis structures and look at the various components that make it up. Then in the next two topics, we'll look at building some of our own Lewis structures so that you can better visualize these different materials around you. So we're going to start with hydrogen gas, one of the simplest covalent compounds we come across. Hydrogen gas is just two hydrogen atoms that have bonded together. So here I've got two hydrogen atoms. It's in group 1, which means it has one valence electron. Remember, hydrogen is one of those very small atoms. It's an exception. It doesn't want 8 valence electrons, it just wants 2. So that first little shell is full. So each of these hydrogen atoms has one valence electron. Each one wants one more. Because they have the same electronegativity though, they're not going to give and take. They both want that extra electron. So what they will do is they will each share their one electron. So that one electron goes into the middle. The hydrogen on the left with the red circle, he can now see 2 valence electrons. The hydrogen on the right with the blue circle, she, why not, can now see 2 valence electrons. Both see what they want, they are both happy. When we're drawing our Lewis structure, we don't draw these circles and dots. What we do is we put a single line between these two atoms. This single line we refer to as a single bond. That single bond contains 2 valence electrons that are being shared by the atoms at either end of that bond. So that is a single bond that we're going to see in these Lewis structures. Okay so far? Let's introduce another molecule so we can look at a new component of a Lewis structure. We're now going to have a look at hydrogen chloride. So hydrogen again on one side, we're very familiar with that one. On the other side I've introduced chlorine. Chlorine's in group 7 on your periodic table, so 7 valence electrons. You can see them drawn around the atom there. Hydrogen wants one more electron to be happy. Chlorine wants one more electron to be happy. So once again, they are both going to share one electron. They each put one electron in the middle. Hydrogen with the red circle can see 2 electrons. All happy, all good. Chlorine on the right can see, count them to yourself, in that blue circle, 2, 4, 6, 8 electrons. It has its stable octet, it's happy. So once again, it's just one pair in the middle. So we draw a single bond to show that those electrons are being shared between the two. But you'll notice there's still these other 6 valence electrons around the chlorine. We do draw these in place. They stay there. These are what we call lone pair electrons. So they're pairs of electrons remaining around an atom that aren't involved in the bonding, but are essential to show that that atom has its octet, that it has 8 valence electrons. So we've talked about single bonds and we've talked about lone pair electrons and how they fit into Lewis structures. Let's have a look at another molecule, one that I'm sure you're familiar with, at least in your day-to-day interactions, oxygen gas. So yes, the oxygen gas that you and I breathe to live is actually 2 oxygen atoms joined together to make O2. So this is the gas that we're breathing, 2 oxygen atoms. Oxygen is in group 6 on your periodic table. It has 6 valence electrons. So they both want 2 more valence electrons. Again, they're not going to give and take. Someone will be left unhappy. They'll share. But the oxygen on the left needs 2 more electrons. Oxygen on the right needs 2 more. So they don't share 1 pair each, they share 2 pairs each. So they each throw 2 into the middle. Again, count it carefully, make sure you can see what's going on. The oxygen with the red circle can see 8 electrons. Oxygen on the right can also see 8 electrons. They're both happy. Because we've got 2 pairs of electrons in the middle, we draw 2 lines to show those 2 pairs being shared. So if a single bond contains 2 valence electrons, This bond here, which we call a double bond, contains 4 valence electrons. Once again, both atoms have their stable octet, both happy. Let's go through one more example so you can see a final feature of Lewis structures. I think you're going to pick up where this one's going pretty early. We've just discussed single bonds and double bonds. Sure, you can fill in the gaps. Here I have nitrogen gas. It makes up almost 80% of the air around us. It's that very nitrogen gas. Nitrogen's in group 5, so 5 valence electrons. That means each of those nitrogens is looking to get another 3 electrons. You guessed it, they do that by each putting 3 into the middle so that they can both experience them. Once again, have a look, count them out to yourself. You'll see that each of these 2 nitrogens can now see 8 valence electrons. They both have an octet. We've now got 3 pairs of electrons being shared, so we draw 3 lines between the 2, and we call this a triple bond. Inside a triple bond, we have 6 valence electrons being shared. So this now allows you to visualize some of the ways that atoms share electrons with one another in order to be able to obtain their stable octet. These are Lewis structures, and they are what we'll be trying to draw in the next couple of topics when we represent these covalent compounds. That being said, if you've been exposed to the world and seen some chemistry diagrams here and there, you may have seen some more artistic looking models like these ones here. So on the top left I've got my acetic acid from my vinegar again. The bottom left I've got ammonia, a common cleaning chemical. The top right I've got urea, which is a very important metabolic chemical. And the bottom right I've got our good friend caffeine. So these are all covalent compounds. We can draw Lewis structures for all of these. When you see these more artistic compounds, and in fact acetic acid here is a good example, you can see that that artistic representation is based exactly off the Lewis structure. They're just using spheres instead of letters to represent the atoms, different colours for different types of atoms, and they use sort of rods to represent the bonds. And you can even see they represent the double bond with 2 small rods together. So they really are adapted directly from Lewis structures. That's all they are. So in this topic, we've looked at the different components that we need to recognise and understand to be able to build a Lewis structure. In the next 2 topics, you and I are going to put pen to paper and start actually drawing these Lewis structures for ourselves.